thank you all for coming out. When I sign up to do these things, I get a little bit of panic sometimes thinking, what if only my coworkers and family come to see me here? But so thanks so much to see a room full of people that are very interested in this topic. I'm going to start off tell you a little bit about me, and I do this not because I'm a huge egoist and I want to start this way, but I do this because I think it helps set a little bit of context for my background and what I've been. Our background and our experiences really influence a lot about how we solve problems and evaluate technologies in the work that we're doing today. So I've got about 20 years of technology experience. I've done everything from kind of started my career in custom development. Started as a middleware developer, kind of moved up to do a full stack. I mostly did C++ and then on to .NET, C#, SQL type development. Now I've kind of moved on to Ruby because I spend a lot of time doing Chef these days. I've been a solution architect. I've been an enterprise architect. Kind of in the theme of the conference, I've built myself up in a lot of skills and then decided to change those skills and build myself up again in some new skills. And that's what I'm doing today. About 2 years ago, I was a solution architect for one of our largest customers, selling our products and doing solutioning. I was asked to come back in and do some DevOps transformation work at CSG. I said, I don't really know a lot about DevOps, and that was 2 years ago. I've really thrown myself into that and really became, as Barry said this morning, an ambitious new version of myself to tackle this for CSG. Part of that has been a big part of being a chef evangelist at CSG and really all things automation that we want to do. And what we're going to talk about specifically today is how we adopted Chef for use with compliance at CSG. Part of that, and we'll go into a little bit about what CSG does, but a lot of what we do is involved in payment processing, and as that we are subject to the payment card industry's specifications. And so last year I actually became a payment card industry professional, certified, and so a lot of that was born out of our experiences that we'll go through today. You're probably wondering, CSG International, I've not really heard of that company. I don't understand who you are or what you do. We don't have a brand name like Toyota or Ford, some of the other companies that are here that we've seen so far. We are kind of, in a lot of ways, the company behind a lot of companies you do recognize. We service a lot of the world's communication companies, from really large ones like Comcast and Telstra, Charter Communications, down to some smaller ones, especially in the broadband and satellite provider industry here in North America. But we have about 3,300 employees globally. So we're good size. There's certainly companies that are much bigger, but there are many companies that are much smaller too. So we have some good amount of experience with scaling our operations up. The industries that we serve here really, our core business is in revenue management, billing, back office systems that we use to service the customers like Comcast, Charter Communications, Dish Network. And we've extended out to a lot of the new types of experiences and technologies that many of you interact with today, things like internet TV, digital monetization, and the new digital economy. But back to our core business, we've been in it a long time, over 35 years, and we support a lot of critical operations on behalf of our customers. We have millions of subscribers in the cable and satellite industry today that rely on our services to work every day correctly with high resiliency to make sure that they can watch TV, our customers can process payments, and service their customers. As part of this, I mentioned process payment. We have a pretty good-sized financial services platform and implementations, and this is where we really start to cross over into our subject and experiences with the payment card industry. It's kind of an obligatory slide that I think always comes up with any kind of security talk, right? Which has a list of recent breaches that come out, right? So. Pulled a couple of these from some recent and just over a year headlines about many companies being exposed and having personal data for millions of customers, credit card data, other sensitive data hacked and leaked out onto the internet. kind of put it down there at the bottom with your company name here. So this is usually the #1 fear of your chief security officer, right? Keep my name out of the Wall Street Journal. I don't want to see CSG International or the name of your company in one of these types of headlines, right? And as Barry went over this morning, right, when he had that kind of like the bottom line, I think, was avoid being hacked, right? It's just another thing that they've piled on top of all the other to-do of work lists that we need to do. And I like the way Barry put it together as well and said, you know, there is no fast and slow. There is no, so this is somebody else's problem. Like we do the fast side, somebody else does the security side or the slow side, right? All of that is all one thing that we all have to worry about every day as practitioners of development and operations. So let's take a step back and talk a little bit about PCI. Just as a quick question, how many of you guys are familiar with PCI or PCI DSS? Okay, so pretty good amounts, probably why you're here. But we'll kind of go over it for those of you that aren't very familiar. So the payment card industry has developed a data security standard. It's a set of these security standards that are designed to ensure that all companies that accept, process, store, transmit credit card information can maintain a secure environment. Try to prevent those headlines we just saw there. This applies to any organization, no matter how big or how small. And a lot of times people think about things like, oh, well, this must only apply to, say, Verifone and those little swipe transactions that you do, like at the retail stores or gas stations, something like that. But you can also be affected if you're a service provider, which CSG is. So any business, you may not be a payment brand, you may not be directly involved, but you actually are directly involved in the processing of storage or transmission of cardholder data. So we have web services, applications, things that take cardholder data in off of a web form, desktop application, and it passes through our systems. And so therefore we're a service provider and we're subject to PCI. Put this up here because PCI DSS, as I began to learn last year, has 12 simple rules. You might think, say, oh, there's only 12 rules here, right? So this, of course, is something that we can get our hands around and do quickly. And that's not actually the case because each one of these rules has a .1, .2, .3, .4, .5, and so on behind there. So at first blush, you might think, oh, this won't be so hard for us to enforce, but it actually is quite invasive below that. Fortunately for you and for me, we are not going to detail all 12 of these today. But I did want to highlight a little bit of some of our experiences in Rules 6, 11, and 12. So developing and maintaining secure systems and applications, regularly testing those, and maintaining security policies that address our whole information security policy. So kind of alluded to, like there are the sub-bullets. So in this case, I pulled out just a couple to talk about some things that we were really affected by. In 6.1, establishing a process to identify security and vulnerabilities, ensuring that our policies are operational procedures, that we maintain secure systems, and that we have all of these documented, in use, and known by all affected parties. And we have to make sure that these security policies and procedures are regularly in use, tested. Did I just copy that twice? That's kind of funny. I don't think that was intentional there. Sorry about that. Yeah, so we ensure that all security processes and operational procedures for monitoring and tested are documented in use and known to all affected parties, right? So we have to know how to build and maintain these things, and we have to know how to monitor them and keep them in compliance. And if you kind of look and you work with an auditors, they'll give you some guidance about how to go through these, right? So they'll say, hey, in order to meet the 6.1 requirement spirit, we want to make sure that you can tag all software assets that are used for developing applications, and we would like an explanation of what function every asset provides, right? So we want to make sure that you can justify why these software assets are running on a server, why even those dependencies those software assets require are running on those servers. We have to implement risk assessment, right? So we have to have the ability to identify threats and vulnerabilities. And that means we have to understand what is running on our systems, right? So how many times might someone come in and say, hey, there's a new known vulnerability in something like C or Java library, Ruby library, Ruby itself, those types of things, right, that many of our applications may be using. We want to know if a vulnerability is identified, which applications are using those technologies so that we can go about remediating them. And we need to check and update this throughout the year. So that's some pretty heavy guidance, and this is something that we were really affected by when we came in. So I want to talk a little bit about our journey through PCI. And I got this slide from our security team that recently kind of outlined this for us, and I kind of liked it, so I repurposed it a little bit for this meeting. But back in 2016, our culture at CSG, we were just very dawning to become aware of how important security was going to be going forward and what we needed to do. Many of our controls at that time were kind of spontaneous, right? So if something came out, then we would have to just pick up and start to say, well, how are we going to remediate this, right? We didn't have very much planning, understanding, or awareness around any of these things. The knowledge was very isolated. It might have only been available to a handful of individuals in our information security team, right? Product management, I've got features to build, I've got products to ship, I don't care about security, know about security, those types of things, right? The mentality was very much like, I don't know what you're talking about. We got a little bit better in 2017. We understood things better. Now people were generally aware that this was very important to us. The overall knowledge was still a little bit low. People didn't know all the 12 simple rules, or much less anything below those 12 simple rules. The controls were still kind of reactive, and the culture was, this is something that is happening to us, right? It's not something that we're driving. It's just something that is happening to us. It's an unfortunate cost of business that we're going to have to maintain here. And now we advanced a little bit better into 2018, and our culture now is that CSG is actually driving our security policies, right? So we actually now really understand what PCI is. We've broadened our knowledge of that. I think we've certified, I'm one of them, the PCI certification that I did, but we have dozens of other individuals that are certified, and we're trying to move that up into hundreds, right? Product managers, senior management, developers, operations folks, everybody is going through this so they can understand that it's how important it is to the business and that we can help incorporate that into our planning and driving that. And our mentality there is very much much more agile, much more agility to be able to incorporate our security into our planning that. And where we want to get to in 2019, right, is the full kind of DevSecOps type model, right? We want to consider building secure applications, monitoring for security, achieving compliance is just business as usual. It's what we do. It's continuous, comprehensive. Our knowledge of this is pervasive and high, and we're a very empowered organization to do that. Many of you may be on a same or similar type journey. I want to talk a little bit about the term compliance theater. So I want to put you guys into the theater mode right now, like imagine the lights dimming down because we're ready to watch a little theater presentation here. The term compliance theater actually, in my mind, I believe originated from Chef's own Scott Ford when he first started coming out and talking to us, who mentioned that his colleague called the process of going through a audit compliance theater, right? Something that we don't do every day. It's a production that we put on one time a year so that we can get our compliance and move forward. So I'm going to talk a little bit about what that looked like at CSG and how we came to realize how costly this was. Of course, started with our first actor, the auditor that came in. The auditor would usually work with our information security team and say, they would say, here is the build and maintain documentation that you've requested, right? You know, how do you build and maintain your software, your servers, those things, so you understand what's on them and when there might be vulnerabilities and those things. The auditor looked that over and kind of said, okay, like I've sampled some of your servers and there are more than a couple that don't actually match very closely with what you said that you did when you built and maintained these, right? Why is that? Of course, our information security team said, well, I don't know, let's ask the DevOps teams, right? Like, and the DevOps teams look at this stuff and then they start to say things like, well, I can't upgrade that version of package, like that's what's there. I don't have any idea why these ports are open. Do we really need all these packages installed, right? Like when we actually look at a server, there's a lot of packages there. People didn't always understand what dependencies were there or why. We'll talk a little bit more about some of the reasons for that. But of course, information security generally at that time was kind of like, well, this is why we need to lock everything down, right? No one can do anything because you guys mess it all up. You change all of the stuff, and we can't keep the specs up to date. It gets in trouble with our auditor. And it gets worse. Executive management comes in. Executive management says, hey, is this audit done? Because we got to get back to our regular work, right? And senior management has to say, well, there's just a few more cycles because we have a little bit of a problem, right? And we go back and we go through this over and over and over again, right? Comes back, says, update these specs. Everyone scrambles around. We do the theater. Finally, we get finished. The auditor kind of says back to the executive team, you know, hey, we got through this, but before I come back next year, because you have to do this every year, I want to see some improvement in these procedures, right? I want to see that you are better at this next year than what some portions of what I saw today. So many companies, you may be one of them right now, or this may have been you in the past as well, kind of went through a lot of this compliance theater. And it's very, very costly. And this is maybe something that not everyone really understood very well. But when you take about all the people that we had to have, we went through all of those actors there, and how much time they had to spend over how many weeks, how many iterations, all of that. When we kind of look back and total this up, there's 20,000 hours, right? It's probably even maybe a little bit of a conservative estimate sometimes, right? It would take us 24 weeks to get through all of this. So it would go from like January to June, and then you have to start again next January. So you really had this like problem, right? It was you could not keep up with this because the requirements were going to keep getting more stringent. The auditors were going to keep asking for more documentation and more proof that you actually are living these security values as part of your DevSecOps and not just doing the compliance theater one time a year. So it was not really sustainable at all, and it was costing us a lot of money. And in some cases, like at your company too, like some of this stuff maybe you may think this is obvious to you or to your colleagues, but the importance of metrics in what we do is pretty key because it's not always obvious to all levels of the organization exactly how much time and money is being spent here, right? That's kind of like that little part of the theater where executive management says, why isn't this audit done, right? Like I thought it was an audit. 1 week in, 2 months in, whatever, right? This should be done and wrapped up, right? Instead, right, it's costing us 24 weeks and all these people are busy doing something that is not adding bottom line value to our company. So what did we find when we kind of looked at this? What were the roots of all this like enterprise variance that we had to do this? The drift, right? So this long-lived infrastructure that we had that was going to drift over time. And a common reason for this is that if you have these servers that are out there and they're running in production, you have production instances, production defects, incidents, things like that. Developers, anybody, people will log in. They might have to install some debugging tools. They might have to install an editor, right? Like, oh, I need to put Notepad on ++ on this thing so I can edit a config file to fix this production instance, right? They fix it, they log out, everybody's like, hey, great, our incident is cleared, but they've left footprints behind, right? Now I've got a variance on that server that didn't exist. And that happens a lot, right, in that drift. And there's also the shift, too, that we saw, too. So as time goes on, your build standards are getting upgraded, right? So you say, hey, like here's some better libraries, here's some better ways that we want to do this, here's new security network or other management tools that we want to have installed on these things. And a lot of times we'll start building new servers or infrastructure with the new tools, but everyone runs out of time and they can't go back through and they can't update all the tools on the old servers. So then again, when the auditor comes in, he says, well, I've got 30 servers that look like this, and 50 that look like this, and 75 that look like this, and so on, right? And so that becomes really kind of difficult to manage in that shifting environment. And then again, a lot of times, even when you are good at remediating a lot of that, you may not remember to go back and update your standards documentation or create corrections, right? So I may actually be pretty good at keeping my running servers and infrastructure up to date, but when it comes time to provide the documentation to the auditor, oops, we forgot to update that the whole year, and I'm back in the compliance theater thing, right? I've got to spend time to go through and do all of that. And then finally, fear. I couldn't find something that rhymed with drift and shift. So, fear here was uncertainty in replacing this infrastructure. This was a big eye-opening thing that I went through when we started with Chef and these things. It was kind of like, well, of course we're going to build infrastructure as code. We're going to rebuild these servers. Like everyone is going to be in the new utopia where we've shifted everything left and we can go through all of this. But you realize, like the previous lack of any infrastructure as control, the build documentation errors that we just talked about in the shift, and the lack of any kind of standardized reporting or auditing tools doesn't leave anybody with any confidence that you can actually do that, right? A key thing in automation is don't automate a process that you can't describe or do manually already, right? So even if I gave teams in operations and development teams the tools and said write code into Chef cookbooks to deploy new servers, a lot of times they just couldn't do it very effectively. They didn't have a good understanding of what was already out there so that they could understand how to rebuild that. So again, we talked a little bit about where we wanted to get to. This is again from our security group about a lot of our principles and best practices. And when we talk about shifting left, right, moving out of just responding and being reactive and spontaneous on incidents into the prevent. And a lot of that is where the asset management, configuration management, and secure development practices come in. And this is where we decided to invest around Chef and automate and compliance. So rather than start off by trying to get everyone to get cookbooks written and to deploy their applications onto new servers, we said let's take a step back and let's focus on asset management and secure development practices and understanding what's already out there in our ecosystem. So automate gave us a lot. And Chef, and we had some good ideas of what we wanted to do there, but we had a couple of other solution requirements that we really wanted to do. I talked a little bit about these build specifications, right? So I need to understand, sorry if it's a little scratchy there. I need to understand not just what's on my server, but is that supposed to be there? Is that justified, right? If this port is open, the auditor wants to know why is that port open, right? Like, oh, well, my application sends and receives traffic on that port, and so that's why it's supposed to be open. Why is that package on there? It's a dependency of my other package that I need to have installed on there. So this was a big thing that we didn't have out of just Chef Automate, right? So Chef Automate was good at saying, inspect, we could write controls and say what packages were on or off the server, but we needed the justifications and we needed the ability to generate the documentation that we wanted for our auditors. We decided that we really needed this to be intuitive and easy to use for a large number of teams. When we first started out, we thought, well, why not just give teams the InSpec and say, write your InSpec control, and then we'll put that in and run that with the audit cookbook. And InSpec's pretty intuitive, right? They've done a lot to make it so that it's easier to write English-like controls in there. But when you're talking about trying to get this done quickly by a large number of teams, and some teams, might assign this to someone like slightly less technical, it was going to be difficult for them to get through that really rapidly and quickly. So we kind of said, hey, like let's go ahead and create an easy and intuitive interface for teams to do a large number to do a large number of these application and specs quickly. And then we have to allow for this continuous daily audit against these specifications, right? These things change really rapidly. So we needed to make sure that, again, we could do this continuously and not make it a theater exercise that happens once a year, right? So again, Chef was well suited for this because we could set it up to run every 30 minutes, every 24 hours, depending on how what we wanted to do, but it was at least able to run continuously. And we also wanted notifications of out-of-date or incorrect specifications, right? So if something broke, something got added to the server that wasn't supposed to be there, something got removed from the server that was supposed to be there, we wanted a notification to go out to the team to let them know that that was a variance and they either need to update the spec if that's by desirable or otherwise remediate that server. And we used Chef Automate notifications was a great fit for providing that notifications, very similar to the demo you saw this morning when they put it on the Slack channel. And then the last two things were key things too. We wanted to actually allow for server asset classifications around scope and priority. we run about 6,000 servers or so in our data center, which is a good number, but not as big as some of you might already have, and some of the other numbers I've heard thrown around, like 16,000 or 30,000. But it's a good number, right? Something that that you need a lot of reporting and ability to clarify around scope and priority. And so we actually added some additional metadata that allowed us to subdivide the reporting of those things, so we knew what to focus on and make sure we were in good shape on our most important scope. And then finally, the should support the roll-up and drill-down reporting for management. So this was another key thing. We talked about the executive management, the senior management, always wanting to know, when's this audit going to be done? How much more work do we have to do? What % complete we're on, right? Everyone always wants to know what we have left, how different people are doing those things. So this was another key solution requirement that we wanted to get in. So what did we do? We came up with a solution that we built that we called the Asset Compliance Tool, or ACT. CSG, I guess because our name is a 3-letter acronym, we like to call everything that we develop is also a 3-letter acronym. So in this case, we have the Asset Compliance Tool. And I'm going to kind of work through the stack of like how we built this. It's actually built on something that we already had in place, which was our Global Asset Management, GAM, because we like 3-letter acronyms. Global Asset Management was something that we had in place already that had an inventory of everything that we had in our data centers, right? Virtual, physicals, networks, firewalls, servers, those types of things. What OSs they were running on, those types of things, right? And it also had the ability to extend a lot of metadata, right? So it had who's responsible for these servers, what are their functions, right? Like what's the server owner, the operations teams, or the DevOps teams that own these servers. So it had a lot of extra metadata about who those servers belong to. So we were able to take a lot of that existing data we already had, and then we were able to define some new schemas that allowed us to define our application and platform specifications. So this again is what should be on these machines to run the application or the OS packages and OS level features, and then also what needs to be on there from a port specifications, right? So which ports should be open in order for these servers to be functional. So again, we augmented the database to capture that level of information, and then we tied it up with our Chef and InSpec reporting, right? So we have Chef Client installed on all of these servers. They are running the audit scans, the audit cookbook against our custom InSpec profiles, and they're sending that data back. So we can aggregate all of the data together between our global asset management database, the extra schemas that we added there, and the data we got out of Chef and InSpec, and we put it all under a nice UI that's got reporting and filtering and some analytics about the state of our systems that we have there. So again, we were able to use Chef and InSpec as a real base with Automate Chef Server and augment with some additional development. And you'll see the classifications there in the data center inventory on the right side, A, B, and C. So this helped us, again, prioritize and scope our servers down. So in the PCI world, we call Class A servers are ones that are directly processing or have payment card data run through them, right? So they're very sensitive. They're kind of the highest level of priority to make sure that they're really secure because they have payment card data that's traveling through them. Class B servers are servers that usually have some type of connection to an A, like they may there might be a logging server where A is sending logging data to another server. That would be a Class B server, those types of things. And then finally, we have Class C infrastructure, which is kind of the third-tier priority. We still want those to be secure, but they actually are not processing payment data. They're not connected to a system that's processing payment data, so therefore they're a little bit lower priority, right? And so by defining those things that way and updating our global asset management with that, we were able to then prioritize how they could appear in the asset compliance tool and tell teams focus on these servers first and these servers second. So again, I kind of went over to high level what some of these components are, but if I kind of go down this a little bit, we talked about the global assets management, the SQL Server database that we have that is getting a lot of automatic discovery of our asset data from the data center. We augmented that with another SQL server and running in ASP.NET application that's running in .NET Core, and that what it allows us to manage our platform and application specification for use by InSpec. It correlates the data that we were getting from GAM, and we kind of have all this together. It also is able to extract data from Chef Server Automate, so we use the compliance APIs and we pull the compliance runs out of Chef Automate so we can correlate it with this information as well. And then we have the reporting and analytics on top that allows us to do the drill down. So if I kind of just go through some quick screenshots so you can visualize what this looks like. Again, Chef Automate, you're probably familiar with this. Here's an example of where one control has failed, where we do not expect that the Linux package DS agent to be installed on this machine. And it actually is, so that's a compliance failure that we would need to go figure out why, right? Should this be uninstalled, or is DS agent supposed to be on there and we need to add it to the spec? As an example of the interface for the ACT tool, so again, we have lists of servers. We have a couple of buttons, one that links us directly to the Chef Automate report, a couple other ones that link us back to the build specs and the port specifications. A build specification generally looks like this. For this server, it's supposed to be running on this OS. This is some descriptions of what the application on that server does, and here are the features that are on that server and what their justifications are. So this is a nice, real clean way that captures all this data. We can export it. We can give it to the auditor. It's updated and compliance checked. Again, every 30 minutes, every day, right? We can keep these things in sync and make sure that our documentation of what's out there is always matched up with what's in our data center, and it helps make the auditor a lot happier. Same thing by ports. So we can go through and do our different ports, justification for what's open on those ports. And then, again, we talked about the executive scorecard. So we can roll this up and give higher level senior management reports for how many servers does your organization own and how many of them are compliant, not compliant. Gives the senior management a quick way to go through and make sure that their organization is compliant. So what did all this lead us to? So again, before we were in compliance theater, doing this really, really quickly, and we were in compliance theater doing this not really quickly. We were spending over 20,000 hours to get this done, and then after we deployed this, right, we were able to do this with much less resources because this is happening small change a little bit every day, and we're keeping on top of it, and we only takes a couple people to look at those reports for 5 minutes a day and figure out what's going on. We get a huge reduction in that, right? And a little quote here from our CISO that kind of said, hey, before we were doing this, you know, we spent tons of hours that we talked about, and it was the best we could do was kind of do some sample set checking because there just wasn't enough time to do that. But now we can go to sleep every night and know that we're not going to be on the page of the Wall Street Journal because we have much better compliance checking. Just real quick, because I want to wrap up and get to any questions, but just in case you were a little bit of like, well, what does this look like in code? This is an example of a custom resource we wrote that just basically we get some node attributes out, we build a query, and we send it to the ACT database, and then we get that JSON back from there, which is what our build spec is, and we just merge it into the attributes for the audit cookbook so that it's available. So then the audit cookbook knows what's available or what the specifications are supposed to be, and then we have a control that goes through and says, well, like, look at the specifications and find the installed features on that node, and if those installed features are not supposed to be there, then you know that's a compliance failure. So we have several of these controls, but they all kind of follow a similar type pattern. Get the data from the ACT tool, and then run during your audit dynamically. Compare that to what we find on there. I'd love to stay and chat a little bit more. You're happy to find me afterwards, but I need to free up the room, make sure the next person can get in and do this. So thank you.